So welcome to Introduction to Knowledge Graphs, Graphs 101. And I am here with my friends and coworkers, Bob Kasenchak and John Tulinsky. And they've got a very densely packed presentation today. This is honestly probably about like a semester's worth of introduction material shoved into about a 45-minute webinar. So it's going to be bursting out of the seams, but hopefully you'll find a lot of good usable stuff. You'll get kind of a better understanding of graphs, and especially knowledge graphs, and kind of what they're useful for and why they are getting to be so popular, both in information and knowledge management, but also in artificial intelligence and the LLM space. So I am going to let the hosts go ahead and introduce themselves. If there's
Okay.
anything extra you'd like to say before
No,
we
that's
get
great.
started.
Thanks, Eric. I'm Bob Kasenchak. I'm a senior information architect at Factor. We're glad to be here today. We've done this year a couple of knowledge graph workshops at conferences. One of them was a half a day, one of them was about a day and a half. And we've tried to pack that information into a webinar sized format. So this will omit some details. It is decidedly not technical. This is not a technical overview. This is a what can you do with it overview. So it was hard to decide what to leave in and what to leave out. And we look forward to feedback on our material. And I'll turn it over to John.
Yeah, thank you, Bob, and thank you, Eric. Good morning, everyone, afternoon, depending on time zones. And yeah, I'm John Tulinsky, and I'm also a senior IA with Factor. And I just noticed that my Factor background is backwards. So
Only to you. Yeah, it
so
shows backwards to you, and we all see it regularly. Yeah.
Oh, okay.
Sorry.
Well, all right. Well, that's shows that I'm not super familiar with Zoom. But anyway, yeah, as Bob said, we've delivered, this presentation a couple times, a much, much longer version of it. And so looking forward to, giving this kind of higher level, technology agnostic viewpoint that hopefully will, help you understand, what knowledge graphs are and what you can do with them. And so, okay, I believe that I am up first. So Eric, can you go to the next slide?
That's me.
Yeah, that's Bob.
Oh, sorry.
No worries. All right. So how familiar are you with knowledge graphs? I know this is a 101 introduction, but we don't come in with the assumption that people have no knowledge of it or no experience with it. So if you could just want to drop either a comment or a number in the chat and let us know how familiar with you are with it on a scale of 1, nothing, to a 4, I'm an expert, and I want to see what you guys say as opposed to what my expertise has taught me. Okay. Microsoft's knowledge graph. Okay, interesting. So a lot of people have, it seems like, some understanding, but nobody really is considering themselves an expert. And I saw a raised hand. Brian, was there, is there something you need to put in the chat, or do you have a question or anything? All right, cool. So 2s and 3s pretty much across the board. A few 1s, awesome, welcome. Hopefully you get a lot out of this. Cool. All right. Bob, there we go.
There we go.
Oh,
that work?
And you're muted, John. There you go.
No, and that's me. Yeah, so again, thanks for joining us today. And we just want to start with a little bit of a, discussion of like what exactly is a knowledge graph? And when people, talk about it, and and you see visualizations, you typically end up with something, like you have on the left, your classic kind of boxes and arrows kind of diagram. You have icons and colors and arrows going here and there. Maybe it's an interactive visualization that you can zoom in, and other attributes will appear. um, but in reality, when you actually interact with an application that's built on a knowledge graph, it's much more likely to be something like you see on the right, which is just a boring old search search UI, or maybe an advanced search with a few filters and things. And so what we're going to be doing today is trying to bridge these 2 points of view, where you've got um, you know the rich and complex model like you see on the left, and that is supporting a some sort of interaction like you get on the right. And so that's basically what we're going to um, be digging into today. Next slide, please. So basically, a knowledge graph is a knowledge model. That's the key point to remember. The graph itself is a representation of knowledge. It defines the different information entities, and then it shows how they are related to each other, which provides a context. And then when then the next part, which separates, so essentially what I just described is often called an ontology, and what turns it into a knowledge graph is when the graph is enriched with data. Then it's more than just a model. It's a framework that enriches the data, and it supports many different business applications. For example, integration, analytics, any kind of search and sharing, uh, you know, things like that. And that's kind of what we are trying to describe. And the key point here, or one of the key points to emphasize, is that the knowledge graph is valuable not so much as a standalone technology, but because of the business capabilities that they enable. All right, next slide, please. Um, So now, practically speaking, what does this look like? What I've shown here is a few screenshots from the Data Commons, which was originally a project from Google and a number of government and academic partners. They essentially collected a very, very large number of publicly available data sets from, this is economic data, demographic data, scientific data, and then loaded it into a graph database, and then structured it with a, unified and integrated semantic model, with and then supported it with the ability to query it and do data analysis. And as we dig into this, we'll see those are the basic capabilities and characteristics that you see with a knowledge graph. Okay, next slide. So sticking with with this data commons as an example, which we have here the Wikipedia description of it, and it contains the basic characteristics of knowledge graphs, which I alluded to in the last slide. So first of all, you have the graph database. Data Commons is built on a graph data model. It's populated with data, and then it is queryable. So, and then last and certainly not least, it is defined by a schema, in this case schema.org, which is an open access ontology that is that's used in a variety of primarily e-commerce applications, but it's a general purpose kind of knowledge representation, which works quite well in this like very, very large data commons. And so these details about, some of the, these characteristics of a knowledge graph are what Bob is going to be going into in the next, or in a few slides as we move on to the next section. All right, next slide, please. So now everyone likes to show an XKCD cartoon in their presentation. So here's where I did it with mine. And, the title of the slide kind of says it, that there's no standard definition of knowledge graphs that everyone is going to accept and agree to. And I don't think this is going to come to a surprise to anyone. I mean, the like common examples of like what is an ontology, what's the difference between a taxonomy and a thesaurus. Those are things that as IAs we run into all the time. And the same thing's true with knowledge graphs. Different practitioners are going to place, more emphasis on the knowledge part or the graph part, one or the other. Also very important is that the perspective is going to vary by the domain and use case. So knowledge graphs in the big data world that are working at focused on data science use cases are going to be very different in structure and probably scale from a content graph, which is which is common in a lot of business and consumer-facing applications for things like question answering, information discovery, those kinds of applications. So those are just some differences to keep in mind as you're thinking about knowledge graphs yourself, and also especially if you're evaluating platforms and tools to make sure that the that the use case that you have in mind maps to what the platform provides. Okay, next slide. And so just to wrap up this first little section, we wanted to show a few examples of knowledge graphs that are in use in real applications. There are many you can find many examples. These are just a handful of selected ones, but they illustrate the the breadth of what you can do. So for example, with IKEA and EA, you have basically a content graph that's looking at things like personalization, how to enhance product information, search enhancements, things like that are going to really help the online experience for customers mainly. In contrast to that, with what Netflix has done is a little bit different. That they are using a knowledge graph as a key part of their overall enterprise data architecture with this what they call unified domain model, and that is intended to support data integration across the enterprise. Many large number of very large data sets, as well as cross-domain mapping of the terminology being used and the metadata. And then finally, a couple of very common examples that you see written about and spoken about a lot is Wikidata and DBpedia, which are open access knowledge graphs that are built on Wikipedia. These are good resources for practice and, gaining, if you want to just practice queries and data manipulation, just kind of, and get like an understanding of what goes into a large knowledge graph. But they also are excellent linked data sources, and there are many, many applications that, that are built on Wikidata and DBpedia, and bring in that data, which is originally from Wikipedia, to enhance various various applications. And so on that note, I will hand it back to Eric for the next section.
Awesome. Thank you very much, John. So we're curious, like, who's using knowledge graphs, or are you part of an organization that's planning to implement or thinking about implementing, or has in some form implemented some kind of a graph? So in the chat, if you could just put in your number, or you can put in the number or the statement, either one. From one, which is you have knowledge graphs that are actually in use and have been implemented, to planning, to no plans, but you're curious to know more, and maybe it's something that you can bring to a future project, or bring a little more expertise into your organization. Ooh, we have somebody implemented and in use. Awesome. All right. Looks like mostly in the 4 or 5, so would like to, or no actual plans, but there's interest. Someone just getting started. Someone's at about a 3 where they're planning to implement. Awesome. Great. All right. So we have a lot of people who are interested, or or don't really have any plans. So let's talk some more about some use cases for knowledge graphs. And I believe this is Bob. Am I correct?
Thanks, Eric. Now that we've discussed a bit about what knowledge graphs are, or could be, or might be, or aren't, or can be, let's talk about why your organization should care. What do knowledge graphs allow you to do? That is to say, what capabilities are built on top of knowledge graphs? So one important use case for knowledge graphs is as an enterprise integration layer, ingesting and transforming data from disparate systems into a single knowledge hub, a specialized kind of database, a graph database, combining information from other data sources. This almost always includes taxonomies, content, and metadata, but can also include other data sources, products, employee and customer information, domain modeling information, business processes, anything that could be usefully integrated into a single database, whose purpose is to be able to explicate and make machine readable the properties and relationships of these objects. It's critical here to note that the graph is not intended to replace other systems. This is not a replacement for all your other databases. It's an additional data layer, an integration layer that absorbs and harmonizes relevant data from other systems to bring it together in a single information ecosystem. So the data and content that's siloed for business and operational reasons, and silos exist for reasons, can be integrated while remaining in situ in their silos or systems. Now, this obviously requires some integrations and transformations as the data needs to stay current, so cron jobs or sync jobs from other systems to the graph are required for real-time analytics. But if there's one thing computers are really good at, it's sending and transforming data between systems. This allows for things like real-time querying of information across silos, assuming that the required resources are available for these integrations and support. So a specialized version of this unified integration layer specific to content and silos, and critically, its attendant metadata, is very useful for management and analysis of content sets stored across disparate systems. This allows for a single point view of content and associated topics and other metadata associated with the content across silos. So there are some integration and synchronization tasks required here, like I said, but being able to offer up a unified view to query information about your content in, say, a dashboard or a search or browse interface like the ones that John showed is extremely useful. And lots of enterprises, large enterprises, struggle with content analytics across silos. Um, the graph absorbs and transforms data from other sources to match the information model in the graph to provide a single source of information truth across systems and silo boundaries. And we see this all this time with our clients. Silos are very, very real. They exist for a reason, but they also cause real problems when you're trying to get analytics and a unified view done. So one specific instantiation of this content integration layer has become pretty common in enterprise knowledge graph implementations, which is what we call a content graph. So a content graph in our world is a specific kind of knowledge graph that includes models of the content, which often includes topics in the content, authors, other pertinent information represented by metadata, essentially a graph that models the information about your content, including objects that represent the content itself. Although it's important to note, the content per se is not stored in the graph. The content, again, is represented by nodes in the graph. It still lives in whatever system, database, content management system that it lived in. The representation of it is pulled into the graph. So you are not ripping out content management systems and putting a bunch of text in a graph database. But this is how we get to something like the old Google Knowledge Graph, which offers details and information about a concept or topic alongside search results of relevant content about the concept or topic. It's also good for reporting dashboards, answering questions about your content, as well as normalization of things like author names and institutions and other relevant entities, organizations that are represented in your content and data. It should be really simple to say, go to a large organization's content set and browse for all the content that was written by a single author, but that is almost never the case. The example I've shown here, I generated from PLOS, which is the Public Library of Science, an open access journal publisher who makes all their data public, which is great. And it shows the information around, in the center of this tiny graph representation is the representation of the article. The yellow dots around the top left side are the topics in the article, and most of the gray dots are authors of this particular scientific journal article. So all that associated information, authors, topics, journals, country it was published in, the institutions they're associated with, are all represented in this graph. Now, in an enterprise environment, the details and the specifics will differ. You probably don't care what journal something was published in if it's an article on your website, but the concept of a content graph is very useful and I think gaining traction. So content graphs, which are again a particular kind of content-specific knowledge graph, allow you to add a lot of rich context around authors, topics, and other metadata represented on the content, which you're probably already doing, but to unify it across systems and silos and make available analytics around your content, which again, lots of large enterprises struggle with. So if we want to answer the question, how many articles did we publish last year about mathematics from at least one author from Harvard? Or how many of our web pages are about product X? Embedding this information in a graph is a great way to go because organizations struggle to answer basic questions about their content, which for managing content is really, really important, such as, for example, the one shown here. So having all of the data absorbed and unified from silos and systems in a single database schema or information layer can enable business users to interact with the data in real time, usually in the form of some kind of analytics dashboard or query interface for content management. So knowledge graphs can also enable rich content discovery experiences beyond analytics. Terms from the taxonomy or ontology that you use to classify your content make up part of the graph. And presuming they have linked data to sources like John talked about, DBpedia or Wikidata, or good definitions in them, can be combined with traditional search results to provide context and additional information about a search topic. This, of course, is a screenshot from the old Google Knowledge Graph at work. You can see on the right-hand pane a bunch of information about Harrison Ford. The Wikipedia summary, birth date, spouse, children, awards. This is all that stuff on the right is all structured data that comes from linked data sources that are embedded in or linked out from the graph. And then all the entities, of course, hyperlinked in blue, are links to other things that are in the graph. And then on the left-hand side is the traditional set of search results of content about the topic or concept that you search for. So this is one way to structure or to surface your graph for targeted browsing based on an entry node. An entry node is whatever you searched for, in this case, Harrison Ford, without trying to expose the entire graph in a user interface. You get the content on the left, and on the right, all those linked entities basically allow you to browse the graph. Even if you're not in a little diagram with nodes and edges that you're clicking around, you're still interacting with the graph and browsing the relationships between the entities in the graph surfaced in some kind of UI. So it's not just the content objects in the graph that are important, it's the underlying taxonomies and ontologies, the domain model that connects the topics that are also doing a lot of work for you. Because graphs are also useful for domain and business process modeling. Modeling objects, concepts, attributes, and relationships allows you to visualize and operationalize, and by operationalize, I mean absorb into a computer system to use and distribute, your understanding of your business processes, systems, and data flows. This is useful for shared mental models of complex systems, like enterprise information environments. So, like supply chains, information flows, and other domain level information can be represented in a machine readable format. Other use cases can involve employee or customer information for delivering personalized experiences. That is, providing context awareness around discovery and other task based experiences. Someone's logged into your website and trying to do something. If you have in the graph all the pages they visited, maybe you have some awareness of the context of the topics and activities that they do while they're there, things like that. Because domain modeling, which is deeply related to enterprise data architecture, involves asking questions like, what is a product? What is a customer? What is a process? What attributes do they have? And what relationships to other objects in that environment do they have? So graph modeling allows you to design a model to serve specific business goals and needs by being able to flesh out the domain and the business processes. And I would be remiss if I didn't say a few words here about AI. One of the reasons we're seeing a lot of uptick in the interest in knowledge graphs recently is because taxonomies, structured data, well-tagged content, ontologies, and knowledge graphs are all very helpful for mitigating AI error and risk. Out-of-the-box LLMs are not aware of business-specific data in context of your enterprise environment and the domain, and are starved for structured information. Graphs can make them more useful and accurate by encoding information about your specific organizations, use case domains, and so forth, and directing the LLM as part of the prompt by going to the graph for answers. So emerging technologies and techniques that are flying around, like RAG, which is retrieval augmented generation, or graph RAG, are specifically designed to integrate structured data and information from a graph into LLMs to improve accuracy and retrieval. They also allow you to encode organization-specific information, the type of stuff that out-of-the-box LLMs won't be trained on, into your AI models. So now I'm going to, having said all that, I'm going to turn it back over to John to talk about getting started.
All right. Thank you, Bob, for that. And as he said, I'm going to just give a brief look at how you would get started with building knowledge graph and some of the modeling that you have to do, and then point out again, as we say, this is going to be a high level look at the steps that are involved. The real implementation of a knowledge graph project is going to be, which I don't think surprises anyone, is going to be highly dependent on the organizational environment, the technology environment, and all of that. And that's really not in the scope of what we're talking about today. But these will be the basic steps that, regardless of the platform involved, these are the basic steps that you would need to follow. All right. Next slide, Bob. Okay, so to start with, I think, and that, really want to emphasize this. The first step is really, what is the problem that you're trying to solve? So if you want to clearly articulate, what is the goal of the knowledge graph? Why are you doing this? What are the questions it's going to answer? What are the business problems that you're going to address? A project that starts with careful consideration of your user needs and the business problems and those questions, as well as a realistic assessment of what is really possible with your technology environment and capabilities. That's a project that's much more likely to succeed than just kind of charging ahead, and with the idea of like build it and then we'll figure out what to do with it later, which is a mistake that we see pretty frequently. And so, just, like what are the kinds of things that you might, build a knowledge graph around? In the thought bubbles there, I've got a couple of examples that are like real examples from clients that we've encountered fairly recently, and they're, excellent examples of the kind of problem where a knowledge graph could be useful. So the first one, is the typical, it's kind of uh, project management question. Like, what is everyone doing? What's the status of deliverables? Where are the deliverables? All of these things that, are managed separately, and, pulling together a unified view is often like a very time consuming for people involved in a project. But, you know, giving that unified view is a great kind of thing, is a great example of what a knowledge graph is good for. The second, how many people in the office are using PCs? How many of them are on Macs? I mean, that seems like a pretty basic operational question, but again, depending on how your all the relevant data is being managed, it may not be so easy to actually answer that. And it may, in the example when it was described to us, it was like involved a lot of emails, a lot of Slack threads, even some meetings to track it all down and bring it together. So that's kind of a common thread when you're trying to answer a question that requires information from different sources, when there's domain specific context that's important to really understand the problem. Those are situations where a knowledge graph is likely to be a useful tool. All right, next slide. Next slide. So then, with that in mind, you've figured out your use case. What is the problems that you're going after? Like, where do you start? And so the good place, I think, is with this idea of a conceptual model. So what you're doing with a conceptual model is you have representation that's a bridge between very high level information domains and the more granular details of an actual implemented application. So from the someone who's familiar with like more typical sort of relational database modeling, you've got conceptual models, then logical models, then physical models, and this is kind of a similar sort of idea. What you're doing with the conceptual model is you're identifying your key entities in your use case. So that's going to be the people, the places, the activities, things like that, and then understanding like how they're related to each other. so that, like people are based in a specific location. To perform a task, a user needs a specific skill. To use a specific, to use a tool, certain training is um, is required. And so, this is not meant to be too formal. It's really just a way to help you, think about and understand what is the essential information you're needed to satisfy your use case, and then and how is that information connected in a way that's separate from your specific implementation. All right. Next slide, Bob. Um, I think you skipped a slide. Or did we skip a slide? Oh, we did skip a slide. Can go up one. There we go. So, sorry, this is the identifying the data sources and building the conceptual model are things that really go kind of in parallel. It's really kind of a 1A and 1B. I so this I'm apologize for confusion here. This is what I meant to talk about first, but again, they go in parallel. So so I think this can make sense as well. That with you know your with your use cases, and as you're thinking about your conceptual model, you have to identify what are the data sources that you're going to be using. And using like the project status example, obviously team communications are very important part of understanding a project. So that's going to be email, it's going to be Slack, it's going to be meetings. But really, for the full context, you also have to know who are the people involved, what are their different roles and responsibilities, what skills do they bring in, um, what is the project schedule, what are the actual work items, so all these are going to be the sources of truth that paint a picture of the project, and you're going to be like mapping into the conceptual model. Um, and so one thing, as you're kind of doing, like identifying the data sources and building up the conceptual model, there's going to be feedback between the two. You want to say like, okay, we know these are important data sources. Are they accounted for in the conceptual model? And the opposite is also true. Maybe, as you're building a conceptual model, you may realize, hey, we actually are not really keeping track of people's skills or of their training. That's a gap in our data strategy. Um, so that's a value that goes beyond actually building a knowledge graph. Is this helping to understand your data and information environment, and and test it against the conceptual model and use cases. Are you actually you know do you actually have all of the data you need in a form that you can make use of? All right. So I described the conceptual model, and now the next step is then turning that into a semantic model. Um, and your conceptual model basically should define most of what goes into the semantic model. Um, uh, you just need to to formalize it a little bit. So the different entities and their relationships in the conceptual model are going to roughly represent, I mean, that's going to be your key business objects, and the relationships are going to roughly represent triples. And so these are the building blocks. This is what you're going to to pull together into a semantic structure. One thing you will often need to do is work from tabular data sources and figure out how it would be represented in this semantic graph structure. That's a very common process. There's lots of resources describing how to do it, and and this little diagram shows a very simple example of how you can you go from the a tabular approach to a triple based one. And then this again doesn't need to be overly complex. As I pointed out at the very beginning, you have for example, schema.org, which is a pretty basic ontology, but it's the semantic structure for, data commons, which is a very large and, very powerful application. And, so the same is true for a lot of your, um, business problems. And then finally, just again about implementation, that's going to vary, some depending on the platform. But the two main approaches, an RDF graph versus a property graph, which is something like Neo4j, those are kind of different organizing principles for your graph, but the essential principles are going to be the same for like how you go from a conceptual model to the graph. All right, next slide. And yeah, to wrap this up, then again, this is very very high level, but the steps are going to be the same regardless of your implementation. You need to define your business problem and the use cases. I mean, I think that's very, very important, and one of the that I would emphasize as a key takeaway. Then collecting and preparing data, putting it into a conceptual model, building and populating your knowledge graph, which is going to be very platform dependent. And then it's not a one and done. I mean, don't forget, for anyone who's from sort of a UX background, testing, refining, optimizing, and growing, governance, all those questions are very important for, for, moving beyond a sort of a demo or a proof of concept to an actual viable platform that is valuable for your business. And that is it for me. So hand it back to Eric, I think.
If I remember to unmute myself. All right. Thank you very much, John. Cool. All right, Bob, can we go ahead to the next slide? Oh, you already did. Awesome. All right. So, thank you so much for attending. If you have any questions or anything you want to talk about, now is your time. We can go ahead and put it in chat. Some questions for y'all. Now that you've kind of been given an introduction to knowledge graphs, has it kind of changed your thinking on the planning at all, or where your interest is lying? And how do you think you'd start a knowledge graph project? Or if you're working with knowledge graphs already, how did that get started? What are some use cases or domains you're most interested in, perhaps? And we had a couple of questions already. Someone is wondering if you can talk a little bit more about the relationship between knowledge graphs and RAG.
I could talk a little bit about that. So my understanding is that not all RAG, and again, RAG is retrieval augmented generation, is graph RAG. So there are lots of ways to augment an LLM by pointing it to structured data sources. There are particular techniques called graph RAG that definitely use a graph to the graph as part of the RAG, as the name represents, which sort of involves, I've seen this for things like information retrieval as well as business processes or workflows, where you basically direct the LLM to go directly to the graph to try and generate its answers. So the simple answer to the question, can you talk about the relationships between KG and RAG, is that the specific kind of RAG called graph RAG that leverages a knowledge graph is so graph RAG is a specific flavor of RAG that's dependent on graphs without getting into any more detail.
So yeah, basically a RAG is basically an LLM that connects to any sort of an additional knowledge base
Right.
before the prompt is actually sent to the LLM. So that could also be like a vector database,
Often.
or yeah, any sort of or even possibly a traditional database. I'm not sure if that's something anybody does, but any sort of a knowledge base. Yeah.
But and that I think is like graph rag and rag often get used sort of interchangeably, but like more strictly speaking, RAG is usually based on, like Eric said, a vector database, which would be more of a traditional search engine, versus GraphRag, which is built on a knowledge graph. And and there are advantages and disadvantages to each one. Like um, the RAG tends to be higher performance, is my understanding, but the quality of the answer, it doesn't do away. It minimizes but does not eliminate hallucinations and all those other things that are problems. Where graph rag is better at that.
Yeah. And also like that structured data, instead of being used just for a RAG, can also be used in the training data for the LLM. Like you can feed it the RDF as part of the and RDF as part of the training data, and train it on that. So potentially graph data can be used with an LLM without using without the RAG architecture as well, depending on how it's trained. All
So
right.
the
Go ahead.
question about knowledge graphs for metadata, can you clarify that a little bit?
I could talk a little bit about it, maybe while Catherine clarifies it.
Mm-hmm.
So the reason I'm enthusiastic about using knowledge graphs for metadata is in a traditional scenario, you have a taxonomy or taxonomies, more likely, or maybe an ontology, but some store of metadata terms that you use to classify your content, maybe across several different axes. And so you have these terms in a taxonomy and you have content in a content management system. You rip the terms out of the taxonomy, put it in a field in the CMS, and now it's just a word in a field. If in a graph situation, you have metadata as objects connected to content that is objects, that makes things easier to query and manage. And the metadata from the taxonomies or whatever is still connected to the structure that it came from. So it has all of its fields, it has all of its relationships. If you need to change a term, you change it, and it's changed everywhere because all those relationships are maintained in a graph instead of being ripped out of the semantic network and put in a field in a CMS.
Yeah.
For deciding and populating the fields, that's a different matter, I think. Um,
Yeah. And one thing to keep in mind too, that I think it was kind of unspoken with Bob's reply, is part of the graph structure is everything has an identifier. Every object has an identifier. Relationships have an identifier. Bob, you're still showing your screen.
uh,
Um,
sorry.
it's all right.
Okay, here, let me just
So
stop it.
yeah.
How about that?
So when he says if you update a label, that it's everywhere, that's because what the concept that that label is applied to has its own identifier. So even if the label changes, the identifier doesn't. So I just want to make sure that that was clear. All right. Cool. And then we had a question before. Let me. Whoop.
It
And
was about
someone that
ontologies.
asked if you could expand on the difference between ontologies and knowledge graphs.
Yeah, this goes back to what John was sort of laying out at the outset. We attended a couple years back a workshop or a class. It was a class, I think, University of Karlsruhe online, series of lectures about knowledge graphs, and it was very much for computer scientists, not information scientists. And what they were talking about was an ontology. So if you ask a computer scientist, I say glibly, not being a computer scientist, and a knowledge graph is a connection of concepts. And so you have Harrison Ford and his birthday and his children and his wife and all the movies he was in, like the ontology is the knowledge graph. From the information science side, which is clearly where we come from, an ontology, a knowledge graph is an operationalized or instantiated ontology. It's an ontology that's connected to some content. It's connected to some data in a business case. So it's not so you can just go out and start modeling the universe. The guitar is a musical instrument. A musical instrument plays music and makes sound and acoustics. You start connecting all these concepts together, but right, when we say a knowledge graph, we mean an ontology that's connected to content or connected to data so that you can do useful enterprise stuff with it, like improve search and retrieval and do queries and automation and those things that we've been talking about. So the short answer is it depends who you ask. The better answer, I think, from our perspective is once you've constructed or borrowed or developed or whatever your ontology, and you start connecting it to content and you start connecting it to data sources, usually by, from Catherine's question, the application of metadata to it from the graph, that's where a knowledge graph is an implemented ontology. That is just my opinion. John, do you have a different different way to look at it?
No, that's how I would express it as well. And I mean, I think it gets back to, the slide I showed about how people have different ideas. So there's not like a set definition, but my kind of nutshell definition would be that the ontology is a model and the knowledge graph is the, ontology plus data or content.
Awesome. All right. Going back, we had a question about on this slide. Someone had said they found the conceptual kind of confusing. Is there any way you can kind of possibly expand upon it or dive a little bit deeper into what's happening with this model?
I'm afraid that's you, John.
Yeah. I mean, I guess the way I would describe it, it's like, is to remember that this is not intended to be a representation of, um, you know, the technology or or an implemented version. It's a tool to help you understand the information environment. So you might think of it as similar to like a mind map, if that's something you've used. And so again, it is not going to, it doesn't have to be very formal. You can draw a conceptual model in a way that makes sense to you. For me, this is, kind of, an approach that works where you're separating, um, entities, which I'm thinking of more as objects versus an action, so, and not in a formal kind of data-based sense, but more as a, like a business activity. And then, and then, there's no labels on the arrows, but, for example, users receive training which prepares them to execute a task. So, I mean, I understand that this is not a very, this is a very clear model, but that's the basic idea. And if you're building one of these for real, you would want to include more details about, like, in particular, the relationships and how those work.
Yeah. And would you say this is kind of an iterative process? Like, oh, we're adding HR to this, so now we need to look at like skills and training or things like that?
Exactly. Exactly. Y-
That's a really important point. I know we have a couple of other questions we're going to get to real quick, but like that's a really important point. is that one of the properties of ontologies and knowledge graphs is that they're extensible. The way for these projects to fail is to try and model the entire universe at once. Don't model the entire universe, don't boil the ocean. Pick a particular business problem or question that you're trying to solve. Model from there, because you can always add to your model. Like Eric said, you can add HR, you can add whatever. So if your question is, how many blue hats did we sell last year? Clean the data, format the data, and design the model, ingest the model, figure out some way to query it, and then say, okay, now I just want to know how many hats we sold or whatever. Start small, prove the concept that you can make it work in a business environment and expand it. Because just starting with Bob Dylan and his birthday, while that might be a lot of fun to model and it's fascinating, it doesn't have anything to do with the business question that you're trying to solve, and it's just bloating your model out at the beginning.
Yeah. I hope that helped kind of with the understanding of the conceptual model here. If it's still kind of confusing or anything, don't hesitate to reach out and ask for kind of more context, or we'll be happy to chat with you about that. And I know you mentioned cleaning up the data, Bob. So can you talk about the importance of clean data, especially before you start creating your knowledge graphs?
Oh, absolutely critical. It's absolutely critical that you clean and format the data. This is not a situation where you can just dump stuff into it and the machine's going to figure it out. What we're doing is doing the underlying structure of really, really carefully considering the model and the attributes and relationships and the data we put in the store so that the machine can do something like have a bunch of junk dumped on it and try and sort it out. So absolutely just throwing stuff in an empty container and calling it your graph is not going to get you anywhere. It's the precision that we can model with and the accuracy that we're really holding up as the benefit of this technology and these techniques. And so, yeah, getting the data right and clean before you put it in there is absolutely critical, which is really no different than any other data project. But John, do you have anything to add there?
Yeah, I mean, 100% agree. But I would also bring in that's where the idea of your taxonomy as one of your data sources is important. And, so people, taxonomists, library science people tend to think of taxonomy as really often in terms of like a linguistics, which they are. But if you're in like like a corporate data environment, a lot of the application is more for like mapping between, you have the data silos that are using, equivalent terms, but different labels. And, doing that mapping is something that a taxonomy is good at, is one of the main reasons why you have a taxonomy. And that is part of, your, the data, the way that the knowledge graph can support data integration is basically by providing, the mapping between different silos.
I know we're at the top of the hour. I know Eric wants to close. I want to hit really quickly one other question that's in the chat, which is any tips for pitching knowledge graphs to engineering partners? What can get them excited about building graphs over relational databases? This is an incredibly hard sticking point. Most engineers, millions and millions of them, are really good at relational databases and query languages and have little or no familiarity with graph databases and SPARQL query languages. This hurdle, not just the technological hurdle, but the engineering hurdle, it's not rocket science. Any engineer can learn this stuff, but they're not familiar with it. So really helping them to understand the benefits of it is going to get you, or someone who's already curious. If you can find a curious engineer who's a champion, hitch your wagon to that person and do not let go. But but this is a difficult enterprise hurdle where bringing in a new system with unfamiliar technology can be really challenging when trying to get buy-in from engineering teams. And I'll stop there.
Yeah, it might also help too if you can get some data folks really excited about the possibility of like connecting the different silos and stuff, and then together kind of bring that to engineering, because they can talk more about the pipelines and the tech stuff. And I think that'll help like everybody kind of speak the same language kind of and build that overall enterprise excitement. Cool. So
100%.
yeah, it is the top of the hour. We are at time. Thank you all so much for some great questions and some great interaction. feel free to contact us. Our emails are up here. And everybody who attended is going to get a follow-up email. You're going to get access to the video recording, and you're also going to get a overview of the Q&A from this webinar. So thanks again so much. I hope you all got something out of it, and we really appreciate you
Thanks,
taking the
everyone.
time.